Now this question, while it's only worth 4 marks, is one which you can surely score in a matter of 1 or 2 minutes, since it's so easily identifiable. Whenever you see an integral of the form polynomial by something infinitely differentiable, you're always going to be looking at how to use integration by parts, which is the standard method for how you'd always deal with this type of a problem, where you find a polynomial multiplied by a function which is infinitely differentiable. Let's say like x times cos x, or x cubed times e to the x, or half x times cos. Anything like that is a job for integration by parts. This is my favorite method for using it that almost never goes wrong. First of all, you write down which one you want to differentiate and which one you want to integrate. And then on the side, you write down alternating signs. So you're always going to choose the easier function to differentiate, or one that's not infinitely differentiable, like x. So you're going to differentiate x. The first derivative is 1 and then 0. And e to the x, that just stays e to the x all the way. Then you're going to want to draw a diagonal line going this way, and you stop when you get to 0. Then you're going to want to use these signs as guidance for what you write down in your expression. So you're going to have this and that as your answer. So quite simply, the next thing that we're going to want to do is write that down. You can almost do it in one line. You might want to write down the whole UDV thing to make sure that the examiner knows that you know integration by parts, but I'm sure this would do. After this, just simply from reading from that, I can see that the answer would be x e to the x, because that's plus x e to the x there in that diagonal line, minus, alternating that sign, e to the x, and of course plus c, and that would get you all 4 marks without much thinking. Always remember integration by parts when dealing with these sort of problems.